Here's integrated 3. This is problem 11-85A. It gives you a polynomial p of x, and it wants you to write the polynomial in factored form and sketch the graph. So I see that it is a cubic, so I'm going to try to do some polynomial division to break it down into a linear factor and a quadratic factor. So I want to list numbers. I want to try to divide by linear factors like x plus 1 or x plus 2 or something like that. I know this is, so you always put this number in the top box. And then I want to divide by a linear factor, so that's why I have an x right here. And then this has to be x squared because it's an area model, and x times x squared equals x cubed. So in these two boxes, I'm going to get the squared number. Like I'm going to get these two boxes have to add up to negative 2x squared. These two boxes are going to add up to negative 5x, and with any luck, this is going to end up multiplying out to be 6. Now, because this multiplies out to be 6, I'm limited in the linear factors that I could try here. So I couldn't, like for instance, you wouldn't want me to try x plus 5 because 5 times what equals 6? 5 doesn't go evenly into 6. So I only want to choose numbers that go into 6. And so I'm going to choose 1 or negative 1 because that can divide into 6. The factors of 6, right? 2, negative 2, 3, negative 3, and 6, negative 6. So you just start somewhere and you just start guessing. So I like to try, I don't know, I guess I'll try, I see some minus signs. Maybe I'll try negative 1. So if I try to divide by negative 1, we'll see what happens. So x squared times negative 1 is negative x squared. I know these two boxes have to add up to make negative 2. So that would have to be negative x squared. If that's a negative x squared, this up here, when it multiplies with x, it has to make negative x squared. So that's going to be negative x. And then negative x times negative 1 is x. These two have to add up to make negative 5x. Ooh, I think we got lucky. So x plus what equals negative 5x? X plus negative 6x adds up to my negative 5. And so that means if x times whatever's up here equals what's in the box, this has to be negative 6. And negative 6 times negative 1 does equal 6. So that means this here is what we call the linear factor. So this is x minus 1. And this right here, this is my quotient. That's my quadratic factor. And then I don't have to draw an area model. Well, I can draw an area model. I can see if that factors. So is there anything that multiplies to make negative 6 and adds to make negative 1? Well, like 2 times 3, right? So if you know how to factor, you can just, you know how to factor a trinomial, hopefully. I didn't show the whole box, but I think this is going to amount to x minus 1 times x plus 2, because I'm just factoring x squared minus x minus 6, and x minus 3. I'm going to set that equal to 0 because I'm trying to find my intercepts. So from here I'm going to, so what makes the zeros, what are the intercepts? I'm going to get x equals 1, x equals negative 2, x equals 3. So I factored it. And so now I want to draw the graph. And so I know that these are all intercepts. So I have an intercept at 1. I have an intercept at negative 2, and I have an intercept at 3. I know it's a cubic, and I know there's a picture of a cubic parent function on the wall, and that cubic looks like this. So I think my graph is going to look kind of like that. So it's probably going to go something like that. But I can do a little bit better than that because I don't really know how low and how high the points are going to go. But I can look right here. If I put in 0 for x, I can get the y intercept. So I see right here just by looking at this that if that was all 0, I'd have 6 is my y coordinate. So I can go so that helps my graph because look how I was going to make it. I mean, I'm not going to take a really long time. It just said sketch a graph, so I'm not going to go try to find every single minimum and maximum on this graph, but I think this is an okay graph. This is a sketch of a graph. So I've got my intercepts. I've got all my intercepts. So I think that's good enough. And that's it.